And welcome back for the second video for your review of Unit 6. We're going to cover questions number 17 through 26 in this video. So let's go ahead and get started. Hopefully you've already looked these questions over and you know which ones you need help on so that you can kind of go through this and not have to necessarily watch the whole video. You can just focus on the ones you need help on. Number 17, it says a square swimming pool has a cement sidewalk around it. The sidewalk is the same width all the way around. The outside perimeter of the sidewalk is 80. What is the width of the sidewalk if the area of the pool is 225 square feet? We're going to have to think through this a little bit. We have a square pool with a walkway around it. And it says that the area of the pool, so this guy is the pool, the inside, right? That's the pool. I guess I should use blue to represent the water, but that's okay. So we would say the area of the inside shape is equal to 225 feet squared. And then it says the outside perimeter of the sidewalk is 80. So that means the distance around the perimeter of the sidewalk is 80. So the perimeter of the outside equals 80. Well, if the perimeter of the outside is equal 80, we only have to divide by 4 to get each side. So we know that this guy is 20, this guy is 20, because 20 plus 20 plus 20 plus 20 is 80. And then if the area of the inside is 225, that means the length times the width is 225. And since they're the same, we'll just square root that. So we actually get 15 here for the width of the pool. And it says, what is the width of the sidewalk if the area of the pool is 225? Well, this actually is just logical. You can use quadratics to solve this, but you don't need to in any way. We can say, since this length is 15 and the whole length is 15, that the distance from here to here plus the distance from here to here is going to be 5 because we subtract these. And then since these are the equal distances, we would say that this length is 2.5 and that this length would also be 2.5. So not a lot of quadratic work there, but you can set it up as a quadratic. I don't want to dwell on that. That's just answers A there. For number 18, now we're getting into graphing according to solving quadratics. So it says, which represents the zeros of the graph of the function? Select all that apply. So we have this equation that says y equals 2x squared minus x minus 6. And it's asking for the zeros. Well, the zeros mean just another way of saying the x-intercepts. So if I want to find the x-intercepts are when y equals 0. So that'll be 0 equals 2x squared minus x minus 6. Now, I don't know if this factors or not. Actually, if you look at all the options, you get nice, clean, real numbers. So that means it is factorable, and they're rational numbers as well. So it is factorable. So I'm going to go ahead and solve this by factoring. So factoring this guy is going to require grouping because the a value is not 1. So the top is negative 12. The bottom is negative 1. So what multiplies to 12 and adds to 1? That would be 3 and 4. Because I want a negative number, the 4 has to be a negative and the 3 has to be positive. So we expand this to say 2x squared plus 3x minus 4x minus 6. We group the first pair, so the greatest common factor there is just x. What's left over is 2x plus 3. The greatest common factor out of 4x and 6 is 2. And because they're both negative, I'm going to go ahead and take a negative out, because I need it to say 2x plus 3 on the inside. So negative 4x divided by negative 2 is 2x, and negative 6 divided by negative 2 is positive 3. And so our factors are going to end up being x minus 2 and 2x plus 3. We apply the zero product property here, so we get 0 equals x minus 2, and 0 equals 2x plus 3. And then we solve each of those, so x equals 2. Solve this guy, you get negative 3 equals 2x, so x equals negative 3 halves. So our zeros are when x equals 2 and x equals negative 3 halves. We don't write them as a coordinate because we are implying that the zeros, when I say find the zeros, that's implying that y equals 0. So we're already stating that y equals 0. So these two values are zeros. which would be the second option and the last option. And then as a result of that, we're asking which of these graphs matches that function. Well, since we have a 0 at x equals 2, and then x equals negative 3/2 is just negative 1.5, so that would be right here. So we're looking for the graph that has those two zeros, and we can see that that is the second graph. Okay, so the second graph is our option there. It's an ugly parabola, but you get the idea. Okay, number 19 is actually a very long problem. It's giving you two coordinates, and it's saying that these two coordinates are on the graph of a parabola. Now, if I plot these points, 2, 4, over 2 up 4, and 6, 4, we notice that these 2 points are at the same height, which implies that when I draw a parabola through those 2 points, there's actually a lot of parabolas that will pass through those 2 points. We could have a standard parabola. We could have a parabola that's a little bit wider. We could have a parabola that's opening down. In all of these cases, these parabolas have the same axis of symmetry. So we can go through and find the axis of symmetry for each one of the equations that are given. So I'm just going to look at option 1 for now. We got y equals 2x squared minus 16x plus 28. I'm going to find the axis of symmetry. So remember, the formula for axis of symmetry is negative b over 2a. And then we're going to plug in those values. So we get b is negative 16, so that's going to be negative 16 over 2 times 2, which is 16 over 4, which is 4. So our axis of symmetry in this equation is x equals 4. Well, if we compare it to what we have here, because the y values are the same height, that implies that the axis of symmetry sits right in between these two x values here. So we could say that the axis of symmetry of this parabola has to be x equals 4, because 4 is right in the middle of 2 and 6. So the first option is a candidate for a parabola that passes through those 2 points. But let me be a little bit clearer here so we understand what we're looking for. We have 2, 4 and 6, 4 here. Now, we know that the axis of symmetry must sit at x equals 4 because that value is right in between those 2 points. We have determined that this parabola has the axis of symmetry of 4, but we still have not determined whether it actually hits those 2 points, because this parabola could have, I'm not saying that it does, but it could have a vertex that's above these 2 points. And because the a value is positive, that means this guy opens up. So it would look something like this. If that's the case, just because it has the same axis of symmetry doesn't mean it will actually hit those 2 points. So from here, you would have to plug in 2, 4 into this equation to see if that point actually works. So if I plug in 2, I get 2 squared is 4 times 2 is 8. Let's plug it in. Y equals 2 times 2 squared minus 16 times 2 plus 28. So we end up with 2 squared is 4 times 2 is 8. 16 times 2 is 32. And then from there we solve it. 8 minus 32 is negative 16. What do I got going on here? No, sorry. Negative 24 plus 28 is 4. So when x equals 2, y does equal 4. So this point works. And because the axis of symmetry is 4 and the 1 point is on the parabola, that means its reflection must also be on the parabola. And so the first option is an option that will hit it. Okay? You could plug in 6, 4 also, but you would end up with the fact that they are equal. So you would go through the motions on each one of those options to check and see. I'll tell you that the first, second, third, and fourth options all have axis of symmetry of x equals 4. The last 2 options do not have that axis of symmetry, so we can eliminate the last 2 options. The second option, the y equals 3x squared minus 24x plus 48, If you go to plug in these points, you're going to see that it doesn't equal. So the three correct answers in this problem, I'm not going to go through each one, are that guy, y equals x squared minus 8x plus 16. That is correct. And y equals negative x squared plus 8x minus 8. So that is correct also. So that is a very long problem, and I don't want to take up a ton of video time to explain that problem. The bottom line is you got to plug the points in to see which parabola has those points on the graph. Okay, for number 20, it gives us a bunch of different functions. It gives us g of x in an equation. It gives us a table. It gives us values of coordinates, and it says which quadratic function does not intersect the x-axis. So I'm going to kind of break these apart here. Looking at option A for number 20, it says g of x is equal to negative 3 times x minus 5 squared plus 1. And we want to see if this parabola, you see it's a parabola because it's got x squared in it, will cross the x-axis. Now, we haven't really talked about the vertex form yet. This is in vertex form, so it would be a lot easier if we had that. But in order for this to cross the x-axis, we would find the zeros. So we're going to find the x-intercepts. We're going to set y equal to 0 and then solve it from here. Now, if I go ahead and solve this using the square root method, because we already have this already kind of factored out, we're going to subtract 1 from both sides. So we end up with negative 1 equals negative 3 times x minus 5 squared. We'll divide by negative 3, and we end up with 1/3 equals x minus 5 squared. And then we'll go ahead and square root both sides. Now this is the indication right here. Because I go to square root, and I square root a positive 1/3, that means the solutions here will be real solutions. In other words, because I was looking for the x-intercepts, I set y equal to 0. Because this equation has real solutions, that means there are real x-intercepts. So this graph actually does pass through the x-axis. So A is crossed out because we're looking for the one that does not cross through the x-axis. Now let's go on to option B. Option B, it says a function whose graph is translated 5 units left and 4 units down from the parent function. So option B, we start off with our parent function y equals x squared. Well, we know what x squared looks like. X squared has a vertex of 0, 0. And then this parabola, it says, is shifted 5 units left and 4 units down. So if I take this parabola, I'm just going to focus on the vertex. If I translate it 5 units left and 4 units down, the vertex becomes here. Now, if it's translated that way, it still opens the same way, just in a different place. And we can see that this parabola actually crosses through the x-axis as well. So B is not our answer because it does cross through the x-axis. Okay. For C, C gives us a bunch of data points. And I guess the best way to look at C would be to plot those points. So for option C, it says negative 2, comma, negative 2 is a point. It says negative 1, comma, negative 7. Okay, so that's down here. It says 0, comma, negative 10. So that's down here. Then it says 1, comma, negative 11. So that's here. And then it says 2, comma, negative 10. So that's here. So we can see based on these data points, we can actually see kind of what's happening here. You can see that this point actually is the vertex because these 2 points are the same height. The axis of symmetry has to fit in between this x equals 0 and x equals 2, which means the axis of symmetry is x equals 1. And this value of negative 11 is where x equals 1. So we know that this is the vertex, which means everything is a reflection upon that line. Okay? This point reflects over here then. This point reflects over here, and if you graph that parabola, we can see that that parabola actually crosses through the x-axis. So C is not our answer either. For D, it looks like we have the same thing going on here. We have some coordinates, so let's go ahead and just plot those coordinates here. It gives us negative 2, 7. Okay, it gives us negative 1, 6. It gives us 0, let's see, 0, 7, so that's back up here. It gives us 1, 10, and then it gives us 2, 15, so 2, 15 is way over here. Again, we can kind of see the trend here. We can see that this is that vertex, and so this graph is going to do something like this, and we can see, therefore, that it does not cross the x-axis. So D is our answer for number 20. For number 21, it gives us a graph of a function. It gives us a graph of a function. Okay, so for 21, it gives us the graph of a function y equals negative x squared minus 8x minus 12. So it gives us the graph, and we'll go back to that later. But it says, what are the coordinates of the x-intercepts of the graph of the function? Now this guy is really easy because it gives us the graph. Okay, so you can see pretty easily negative 2 and negative 6 are where the function crosses the x-axis. And so we have this parabola that looks something like this, right? And it's just asking for the coordinates of the x-intercepts. So this x-intercept is negative 2, 0, and this x-intercept is negative 6, 0. And so our answers are C by just looking at the graph. If we were to do this analytically, to find the x-intercepts, remember the x-intercepts are when y equals 0. So we would just set y equal to 0 and then solve that equation. I don't like the negative there, so I'm going to go ahead and divide both sides by negative 1. So we get x squared plus 8x plus 12. And then I'm going to go ahead and factor that guy, so that becomes x plus 6 and x plus 2. And then we'll set each of those equal to 0 by the zero product property, and then solve each of those. So x equals negative 6 and x equals negative 2. And then we write them as coordinates, so these guys are answers for number 21. Okay. For number 22, this one's a bit of a process. We got 3 different methods to solve an equation. So for 22, we have 5x equals 3 minus 28x squared. And we want to solve this by 3 different methods. So if you think about the methods that we have factoring, we have completing the square, which is also the square root method, if you want to call it that. And then we have the quadratic formula. So we've got to do it all 3 of these ways. In the factoring in the quadratic formula method, we have to make this equation equal 0. So we would subtract 5x, and then we'd put it in standard form. So this would say 0 equals negative 28x squared minus 5x, and then plus 3. And then we'd go ahead and factor from there. When I go to factor, a times c, 28 times 3 is going to be 28 times 3, 24. That's going to be 84, negative 84. And then on the bottom we have 5, negative 5. So we're going to list our factors of 84. That's 1 times 84, 2 times 42, 3 times 28. That's how we got that. 4 times 21. 5 doesn't work. 6 times 14. 7. Does 7 work here? Let's see. 7. Yeah, 7 works. 7 times 12. 8 doesn't work. 9 doesn't work. 10 doesn't work. I think that's all we've got. So we're looking for the one that adds up to 5. And 7 and 12 add up to 5. So it's going to be 7 and 12. it can be a negative 12. So we'd say 0 equals negative 28x squared plus 7x minus 12x, and then plus 3. We go ahead and group those things. So the greatest common factor out of those two values there is going to be a negative 7x. What's left over is a 4x minus 1. Greatest common factor there is going to be a 3, but we want a 4x left over. So negative 12 divided by 3 is negative 4. I want a positive 4. So I'm going to take out a negative 3. Negative 12 divided by negative 3 is 4, and then x. And then 3 divided by negative 3 is negative 1. And then since these are the same, our factors are going to be negative 7x minus 3 times 4x minus 1. And then we'll set each one of those equal to 0 and then solve that equation. So we end up with 0 equals negative 7x minus 3, and 0 equals 4x minus 1. And then solve each one of these. So 3 equals negative 7x, x equals negative 3 over 7. And then here, add 1, and then divide by 4, so x equals 1/4. So these are our two solutions, and that would be method 1, by factoring. We could do the quadratic formula. We should get the same two answers. And then we can do completing the square. We should get the same two answers. So if I were to do the quadratic formula, by the way, before we do those other methods, back here, I could have factored out a negative 1 from everything. In fact, up here, factored out a negative 1 because that's a negative there, and it just makes it a little bit more complicated if the negative is there. So I could have divided everything by negative 1. 0 divided by negative 1 is still 0. So, but regardless, the answers would end up being the same. For method 2, let's go ahead and use the quadratic formula to solve this because we already have it equal to 0. So x equals negative b, so negative 5, plus or minus the square root of b squared, so it would be negative 5 squared, minus 4 times a, so 4 times negative 28, times c, so times 3, all over 2 times negative 28. And then we're going to solve that equation. Negative 5 is 5, plus or minus the square root of 25. Negative times a positive is a positive. 4 times 28 is 112, and 112 times 3 is 336, and then that's all over negative 56. Simplifying that from there, we end up with 5 plus or minus the square root of 361. 361 over negative 56. The square root of 361 is 19, so we got 5 plus or minus 19 over negative 56. And then from here, we could write this as 5 over negative 56 plus or minus 19 over negative 56. We could do that. And I guess let's go ahead and work with that. So we get x equals 5 minus 19 is negative 14, and then over negative 56. Or 5 plus 19 is 24 over negative 56. And then reduce those from there. We could divide those by 14 actually. So this is going to be 1 over 4. And then here we can divide by 2, that'd be 12 over 28, divided by 2 again, you get 6 over 14, divided by 2 again, we get 3 over 7. So we end up with negative 3 over 7. So there's our answers, again, using the quadratic formula. For method 3 on number 22, I'm just going to give you a heads up. This one's really disgusting. We're completing the square to do this, and we have some big numbers. And so it's okay if you got a little bit lost in it, but hopefully you can follow along here and understand what's going on. Normally completing the square is a lot cleaner, but because these numbers are so big, it's not going to be the prettiest thing. So in order to complete the square, we need to make sure that the x squareds and the x's are on the same side of the equal sign, and that the constant's on the other side. And I want to make this a positive coefficient for x squared, so I'm going to move everything over. So I'm going to add 28x squared to both sides. So I end up with 28x squared plus 5x equals 3. Now from here, I need the a value in front of the x squared to be 1. So I'm going to divide everything by 28. And whatever you do to one side, you have to do to the other. So then this simplifies, if you want to call it that, to x squared plus 5 over 28x equals 3 over 28. Now from here, we need to complete the square on this side. To do that, we're going to set up our x. Remember, we don't know what c is, so we don't know what's in this top piece. But we do know what b is. This is going to be 5 over 28. And because these two values have to be the same, and they have to add up to this, we're just going to take this and divide it by 2. So we actually end up with 5 over 56 in each one of these terms, okay? Then from there, we're going to multiply these two things. And when we multiply these things, we get 25 on top. 5 times 5 is 25. And then 56 times 56 is 3,136. Now, we're going to take that value and understand that since a is 1, well, a times what value gives you this? And that tells you that c is actually equal to that. And that's why we always want our a value to be 1 there. From there, we're going to add that to both sides of our equation. So we're going to add 25 over 3,136 to both sides. This gets really gross, like I said. So you end up with x squared plus 5 over 28x equals, plus the 25 over 3,136 equals, now when I go to add these up, I need to find a common denominator in order to add those up. And in this case, the common denominator is in fact 3,136. So we would have to multiply this guy, I believe, by 112 over 112. Yeah, that's what it is. So we're going to multiply this guy by 112 over 112 in order to get a common denominator on that. So we end up with 336 over 3,136 for this one. And then we need to add the 25 over the 3,136 to that. On this side, we can factor this now. And we can go through the big long work, and these numbers are disgusting, or we can refer back to the x factor that we already have, and because this came from that factors. Since a is 1, then our factors are just x plus 5 over 56 times x plus 5 over 56. Okay, and then on this side, we end up with 361 over 3,136. On the left-hand side, we can rewrite that as a perfect square, or a squaring of a binomial. So x plus 5 over 56 squared equals 361 over 3,136. From there, we're going to go ahead and square root both sides. So we end up with x plus 5 over 56. 5 over 56 equals plus or minus. The square root of 361 is 19, and the square root of 3,136 is in fact 56. So that cleaned up nicely. We're going to subtract the 5 over 56 from both sides. So we get x equals negative 5 over 56 plus or minus 19 over 56. And then from there, we just solve it. So negative 5 minus 19 is negative 24, and then over 56. And negative 5 plus 19 is 14, and then over 56. And then these guys reduce. The negative 24 over 56 reduces to negative 3/7. And the 14 over 56 reduces to 1/4. And so that is the third method in solving that equation. And I wouldn't recommend that because the numbers are so disgusting, but that is completing the square. For number 23, it says, what are the coordinates of the x-intercept? Now, we've done this plenty of times here. What are the coordinates of the x-intercepts for y equals x squared plus 8x minus 20? And so remember, x-intercepts are an application to solving equations. We can't actually solve and know what x is in this function because we have a y value there, or we have y, so there is no specific x value. So now we need to interpret what it's asking us. It says find the x-intercepts. And remember, the x-intercepts are when y equals 0. So we're going to take that value and plug it into y. So you get 0 equals x squared plus 8x minus 20. And then from here, I think this factors pretty easily. This is going to factor to x plus 10 times x minus 2. We always want to check our work, so you would distribute all that out and combine like terms. We do, in fact, get x squared plus 8x minus 20. From here, we're going to do the zero product property. Since we're multiplying two terms to get to 0, one of these two terms has to be 0. So we'll say x plus 10 equals 0, or x minus 2 equals 0. And then we'll solve each one of those. So we get x equals negative 10 and x equals 2. Now again, be very careful on how you answer these questions. It says, what are the x-intercepts? X-intercepts are coordinates on a graph. It's where the parabola or where the function crosses the x-axis. So the actual x-intercepts would be negative 10, comma 0 and 2, comma 0. These are my x-intercepts. So this is my actual answer. And just to kind of recap a little bit, I want to make sure you guys understand the difference between the different types of things I could ask for. If I said, what are the factors, then we would only have to get down to this line here. X plus 10 and x minus 2 are the factors. But students often misinterpret or misunderstand what that means. If I say, what are the solutions are the values that x equals from my equation. And then the last thing here are what are the x-intercepts, okay? So if I give you an equation with one variable in it, like this, and I say solve it, this is your answer. If I give you just an expression and I say, or even an equation, and I say factor the expression or factor the equation, then this is my answer. If I say what are the x-intercepts, then this is my answer. Students oftentimes mix these two things up a lot, and they'll say the solutions are 10 and negative 2. No, the solutions are the x values that make each of these terms equal to 0. So the solutions are negative 10 and 2. And then the same thing here, we just are not thorough with our answer, and so students say that the x-intercepts are negative 10 and 2. No, they're not. X-intercepts are coordinates, negative 10, comma 0 and 2, comma 0. So please make sure that you are paying attention to that when you're reading the problem. Make sure you're answering the question that it's asking for. Okay, so for number 24, it says solve by completing the square. Now I promise that this completing the square is going to be a lot simpler than the previous one, and that is simply because the numbers are a lot smaller. The other thing that made the previous number 22 so ridiculous, part of the reason is because the b value was an odd b value. The b value originally was 5, which causes huge concern. And then of course the a value was something other than 1. But in this case it should be pretty simple. We're going to go ahead and move the x squareds and the x's over to the right hand side to make a positive x squared. So we're going to subtract x squared to both sides, and we're going to subtract the 4x to both sides, and then we're going to get this negative 7 to the other side, so we're going to add 7 to both sides. So as a result of that, we end up with 5 equals x squared plus 2x. And we want to complete the square, so we're looking for the c value that we have to add to this to complete the square. So we set up our x. We don't know what goes on top. We know that the bottom must be 2. And we're looking for two numbers that add up to 2 that are the same. So these guys are going to be 1 and 1. And then 1 times 1 is 1. Since a times c is 1 and a is 1, that implies that c must be 1. So we're going to go ahead and add 1 to both sides of this equation in order to complete the square. As a result, we get 6 equals x squared plus 2x plus 1. And then when we go to factor the right-hand side, we end up with x plus 1 times x plus 1, which can simplify to x plus 1 squared. From there, we're going to square root both sides in order to solve this. So remember, whenever we do a square root, it's plus or minus radical 6. And then on the right, we get x plus 1. We'll subtract 1 from both sides. These are not like terms, so we just have to leave it as negative 1 plus or minus rad 6 equals x. And that is our answer for number 24, which is C. All right, last problem, and this last problem is kind of all-encompassing, making sure that you know the connection between solving equations, quadratic equations specifically, and connecting that to the idea of graphing a parabola. So in 25, we're given the equation or the function y equals negative 2x squared plus 16x minus 24. And it's asking us to find the axis of symmetry, the vertex, x-intercepts, and the y-intercept. So we're going to go with part A. First, remember to find the axis of symmetry. The equation for the axis of symmetry is x equals negative b over 2a. And so we just plug that in. So x equals, the b value is 16, so this is going to say negative 16 over 2 times the a value, so 2 times negative 2. That turns into negative 16 over negative 4, which is 4. So our axis of symmetry is 4. For B, it's asking for the vertex. Well, the vertex, the only thing we have to do for the vertex is take our axis of symmetry and plug it in order to find the y value. So we'd say y equals negative 2 times 4 squared plus 16 times 4 minus 24. And we'll simplify that. Remember, we don't want to multiply the negative 2 times the 4. We have to do our order of operations first. We have to do the exponents first. So 4 squared is 16, and then times negative 2, so that's negative 32, plus 16 times 4 is 64, and then minus 24. So we end up with, well, negative 32 plus 64 is 32, minus 24 is 8. So our vertex is 4, 8 as our answer there. For C, kind of running out of room here, it's asking for the x-intercepts. Well, remember, the x-intercepts are when y equals 0. So we're going to set y equal to 0 up there. So 0 equals negative 2x squared plus 16 times x minus 24. I'm going to solve this by factoring because I can see a common factor out of all those. So factoring might work out pretty well. I'm going to factor out a negative 2. So we get negative 2 times x squared minus 8x plus 12. And then I'm going to do my quadratic factoring. I'm going to just do this pretty quick. We've been doing a ton of practice with this, so I don't want to dwell on it. It's going to be x minus 6 and then x minus 2. And then when I go to solve this, I'm going to do the zero product property, but ultimately I end up with x equals 6 and 2. So my x-intercepts, again, are coordinates. So our x-intercepts are 2, 0 and 6, 0. Okay, so that's our answer for C. And then D is pretty easy. It's asking for the y-intercept. Now remember, the y-intercept is exactly the opposite of the x-intercept. If the x-intercept is when y equals 0, then the y-intercept is when x equals 0. Now we already know what the y-intercept is by looking at it, but we want to make sure we understand this. The y-intercept is when x equals 0. So if I plug in 0 to my x's, this whole term goes away, this whole term goes away, they become 0, and we're left with negative 24 for the y value. So our answer for the y-intercept is 0, negative 24. Okay, so those are all the attributes for the graph of the parabola. I'm going to go ahead and erase all this so I have room to graph, but I'll write down those answers off to the side so I don't forget them. For A, we had an axis of symmetry of x equals 4. We had a vertex of 4, 8. We had x-intercepts of 2, 0 and 6, 0. And we had a y-intercept of 0, negative 24. And now we have to graph this parabola. Now, graphing this parabola, pretty easy. it should be easy by now. We have an axis of symmetry of x equals 4. So we're going to go over to the right, 4. And then the vertex has to lie on that. So we're going to go up 8. So 4, 8 is going to be my best attempt at this. That's my vertex. Now from here, I can plot these x-intercepts. That's negative, or that's 2, 0. So that's this point. And then 6, 0 is here. And then we can plot the y-intercept as 0, negative 24, which is way off of our graph, and you don't even have room on your graph to graph it. But now I don't want to stop here. This is not acceptable to just connect these dots in a parabolic fashion because that's really rough. You remember from the previous unit, we can look at the slope pattern in order to determine the next step, okay? So remember, when a is equal to 1, the slope pattern is 1, 3, 5, and then 7, 9, and so on. But in this case, a is equal to negative 2. So we take our original slope pattern and we multiply it by our a value. So we get a slope pattern of negative 2, negative 6, negative 10. So we're just multiplying 1, 3, 5 by the negative 2. And what that tells us is that we start at the vertex and we're going to go down 2 over 1, then down 6 over 1, then down 10 over 1, and so on. So from this vertex, we're going to go down 2 over 1, and then we're going to go down 6 over 1. So we go down 1, 2, 3, 4, 5, 6 over 1. And look at that. We're right on our x-intercept like we were supposed to be. So it's not just I want it to be an accurate graph. It's a way to check that our answers here line up with the slope pattern and the function to start with. Now we're going to go the other way. So we're going to go down 2 and back 1. And then we're going to go down 6 and back 1, and we end up here. The next one would be down 10 and over 1. So I could go down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So going down 10 over 1 puts me about there. Going down 10 and right 1 puts me about here. And then we have our parabola that looks something like that. All right, so that wraps up the review for Unit 6. I hope that helps you out. Make sure that you're studying. Make sure you're going over the problems that you have any questions on. You can go back and rewind and watch the video over 100 times if you need to. Hopefully you don't. But let's get prepared for the test tomorrow. Make sure your notes are completed and your homework is all ready to be turned in.